Hello everyone, welcome to today's class. This is Teacher Simon taking you through Cambridge International AS and A-Level Pure Mathematics 3, Paper 3-2 for October-November 2023, and this is part 1 for questions 1 to 6. Question 1 is coming from modulus functions. Part A, they are saying sketch the graph of y is equal to the modulus of 4x minus 2. Now, if I have y, which is equal to 4x minus 2, I'm going to first consider this one without the modulus signs. Then I find just two coordinates, especially where this line crosses the axis. Okay, so if I have x and then y here, if x is 0, y will be negative 2. Then if y is 0, so put 0 here, bring the 2 here, it will be a positive 2. Then divide by 4, you get a 0.5. So then I'll put down my sketch here. So that is that. Now we can draw 0, negative 2. 0, negative 2 is down here. And then 0.50 is here. Okay. So we are supposed to draw a line which does like this. Cuts x-axis at that 0.5, but cuts y-axis at negative 2. But then, since this is modulus, so we are dealing with the absolute values. So what is negative becomes a positive. Can even make this one dotted or rub it away completely. Okay, so what appears to be a negative here, we reflect it in the x-axis. Okay, so when we reflect it, so here it was passing through negative 2, then it will come and pass through this positive 2 here. So you do this like that. If you want, you can even say this one is for the positive part, which was already positive, and then the one that we have reflected in the x-axis, it is negative of that. You know that when you reflect, if a coordinate was here and then you reflect it in x-axis, first of all it is x, then this is y. Then when it crosses the x-axis, when it is reflected in the x-axis, x remains, but y changes the sign. So because y changes the sign, you can see that this one is a negative here. Okay, so that's why we represent that with a negative. So that is our sketch there. Then part B, solve the inequality. Solve the inequality 1 plus 3x less than the modulus of 4x minus minus 2. So that is that there. Now, meaning that, by the way, here we can do it using maybe 2 or 3 methods. Okay, first I can split. Okay, I can split this. So the modulus has gotten these two graphs. It has gotten the positive and then the negative. Okay, so I can have 1 plus 3x, then less than the positive part. Then I solve this one here. So I will have 3x, then minus 4x, which is less than negative 2, then minus 1. So meaning we have negative x, which is less than negative 3. And then when we divide through by a negative, the sign has to change. So it will be greater than 3. Then, in the other splitting, we also have 1 plus 3x, then less than the negative of this one here. Remember, it has the positive and the negative. Now, we solve this one here, 1 plus 3x. Then when we open the brackets, we shall have negative 4x, then plus 2. When this one crosses here, and then you take the 1 here, the 4 will add to that 3, and then we get 7x here, then less than 2 minus 1, that is a 1. So meaning x is less than 1 over 7. Now, when you split, you have to always test, okay? Test your inequalities that you have gotten, okay? So I'm going to test this one for x less than 1 over 7. Okay, I can take a number like 0. So let x be equal to 0. Then I ask myself a question using what is here. So this will be 1, then plus 0. Okay, is it less than the modulus of 0 minus 2, which is negative 2? So is 1 less than 2? Yes. So that means this is an answer, is a solution. Then I can also test this one, x greater than 3. Let us take a value like 4, x is equal to 4. Then I substitute in here. Okay, so we have 1 plus 3 times 4. Is it less than 4 times 3? That is 12. 12 minus 2. No, I mean 4 times 4, that is 16. Then minus 2. So is 13 less than 14? The answer is yes. So that means even this one is a solution. So both of these are solutions. Then alternatively, we can sketch the line y is equal to 1 plus 3x on the same graph. So we need the two coordinates where that line cuts the axes. So we have x and then y. So if x is 0, y will be 1. Okay, then if y is 0, okay, then we shall have negative a third here. Now we can go here and plot 0, 1. I'm going to change the color and use green here. 0, 1, which is here. And then negative a third. Negative a third is, that is negative 0.33. Okay, so maybe it's around here. Then it is nearer to the 0.5. Now I will draw this one here through these 2 points, and then I continue it just like that. So the fact that in the first one here we have gotten 3, when you remove the inequality signs, x is equal to 3 and then x is equal to 1 over 7. So those are the solutions, okay, where these two meet. So that means by looking at what is up here, this line here is intersecting this reflected part, and this one is the point which is actually 1 over 7 because it's a small value. Then this one will continue. When x is 3, they will meet somewhere there. Okay, so having identified that, now we can proceed and say, let me actually label this one here. This one is y, which is equal to 1 plus 3x. Now I'm going to take these two here. They are already intersecting. So we have here our 1 plus 3x, which is intersecting with the negative. Okay, so we just do the same as this one here. So in order not to waste time, I'm just going to carry this, then put it there. It's the same calculation you do. Okay, that is that. Then next, we also see that these lines are diminishing, so they will meet somewhere. Okay, so this line here meets the positive of this one here. So we shall also have this one here. Okay, I'll just copy it also and put it just down here. That's another calculation. If you did the sketching, this is what you get. And of course, when you sketch and then you prove that these ones are actually meeting, you don't need to test. The testing isn't needed here. Testing is needed where you split here. Okay, So that is that. Question 2 is coming from parametric differentiation. They are saying the parametric equations of the curve are x is equal to natural log of t squared, then y is equal to e to the power of 2 minus t squared for t greater than 0. Find the gradient of the curve at the point where t is equal to e, simplifying your answer. So we need to differentiate this one, the x with respect to t. Okay, so the x dt is going to be equal to, this is now, let me first write something here. When we differentiate natural log of any function, we actually get the function, we differentiate it, and then we divide by that same function. And also when we differentiate an exponential function, we get the power of that e, we differentiate it, then after we multiply by that exponential function. Okay, these two are going to be applied here. Now, dx dt, this one is, we are going to use what we call the chain rule. So first drop this 2 here, then reduce the power by 1. So we shall have 2, then natural log of t. Then the 2 here is minus 1, so you get power 1. Okay. Then next, times, enter inside here and differentiate. But how to differentiate the natural logarithm of a function? We have said, get that function, differentiate it, then divide by that function. So therefore, we are going to get t, we differentiate it, which is a 1, then we divide by that t. Okay, then we come to this one here. dy dt is going to be equal to, get what is here, you differentiate it, you get negative 2t. So that negative 2t you have gotten, then multiply it with e to the power of 2 minus t squared. So meaning dy dx, which is the gradient function, is going to be equal to dy dt times dt dx, which is what we call the chain rule. Why are we doing this? Because this one can disappear with this, and then you remain with your dy, then dx. Okay. Now, this is dy dx. dy dt is given as negative 2t e to the power of t minus 2 minus t squared, then times dt dx is going to be the reciprocal of this one. dt dx is 1 over dx dt. So we shall have t out of 2 natural log of t. Okay, so these 2 can cancel with this one here. And then what do we get? We shall get negative t squared e power 2 minus t squared out of the natural log of t. Okay, then after that, they say that t is equal to e. So for t is equal to e, what is our dy dx? So dy dx is going to be negative e squared, then times e power 2 minus, what is our t here? Is e squared. So put e squared here out of the natural log of e. Remember, natural log of x is the same as saying log base e, then power that x there. So that means if we have natural log of e, this is the same as log e, okay, which is equal to what? To 1. Now, so down here, the denominator is a 1. Now, using the rules of indices, we are going to add these powers, okay? So 2 plus 2 minus e squared. So meaning we shall have negative e to the power of 4 minus e squared. So that is the gradient. Okay, so I can just write gradient is equal to negative e to the power of 4 minus e squared as our final answer. Question 3, the polynomial 2x cubed plus ax squared minus 11x plus b is denoted by p of x. It is given that p of x is divisible by 2x minus 1, and that when p of x is divided by x plus 1, the remainder is 2. Find the values of a and b. So I'm going to use the factor remainder theorem, and then we put that p of a half, because when you equate this one to 0, it will give you a half. So p over half is equal to the remainder, which is 0. Okay, usually we say that p of x is equal to ax, let's say, minus b, that is the divisor, then times the quotient, then plus the remainder. Okay, so if x here is equal to b over a, that means this one will disappear. It will be a 0. Then this whole thing goes. So that means when you put b over a in here, you actually remain with the remainder. So that's why we call it the factor remainder theorem. Okay, so meaning if we get p of a half after equating this one to 0, then we substitute in here. We shall get 2 into a half cubed, then plus a half squared, minus 11 of a half, then plus b. Then we shall equate to 0, because if something is divisible by another, then the remainder is 0. 6 over 2 is equal to 3. The remainder is 0. You see that? Now, simplifying this one, what do we get? 2 over 8, that is actually a quarter. Then also here we have a quarter of a minus 11 over 2, then plus b is equal to 0. So I can actually multiply here by 4. So I will get 1, then plus a here, then minus, of course 2 goes in here 2 times. And then, so 2 times 11, that one will give us 22. Then plus 4b is equal to 0. So the equation I'm going to get here is a plus 4b. 1 minus 22, that is negative 21. Then when it crosses the equal signs, it is a positive 21. So that is equation 1. Then here, when it is divided by x plus 1, the remainder is 12. That means we shall have p of negative 1. Remember, equate this to 0 to get the value of x. This one is going to be equal to 2 into negative 1 cubed, then plus a into negative 1 squared, minus 11 times negative 1, then plus b. We equate this to 12. All the power of a negative is a negative. So here we shall get negative 2, then plus. Even power of a negative is always a positive, so this will be a. And then plus 11, then plus b is equal to 12. 11 minus 2. That one will give us 9. Then when I bring it this side, it will be a negative. So this one will give us a 3. Okay, so I can have a plus b, which is equal to 3. So this is the second equation. Then I can solve these two simultaneously. If I get a plus 4b, which is equal to 21, then a plus b, which is equal to 3, and I subtract them, a will disappear. And then I'll have here 3b, which is equal to 18. So when I divide all through by 3, b becomes a 6. And then substituting, let's say in the second one, a is going to be equal to 3 minus b, which is 6, meaning a is going to be equal to negative 3. As simple as that. Number 4, part A, is coming from complex numbers, specifically loci. On a sketch of Van Agan diagram, shade the region whose points represent the complex number z, satisfying the inequalities, the modulus of z minus 4 minus 3i, then less than or equal to 2, and then the real of z less than or equal to 3. Now, here I'm going to create a negative, okay? So we shall have z minus 4 plus 3i, which is less than or equal to 2. If you have been following me, I have already said that if you see the modular signs on one side of the equation, then you know that that is a circle. Of center, this one, we have z minus u, then less than, let's say r, less than or equal, or maybe it is just equal. This one here, the center of that circle is this u, and then this one is the radius. Okay, now what we are going to do, this one is going to be a circle of radius 2 and center 4, 3. Okay, and center 4, 3. Now when we draw that circle, the circumference is going to be bold. Why? Because it is less than or equal. If it was less than, then we would have drawn the circumference dotted. Why? Every point, now like for this one, every point that is inside the circle here is considered because of the less than, and also a point that is on the circumference of a circle, which is exactly 2 units from the center, is also considered. Okay, so that's why this one happens to be bold. But if it is for less than, we only want the points inside here. We don't want the points that are on the circumference of a circle, because for them, they are exactly 2 units from there. You see that? So that one, we are not going to have it there. Now, what else are we going to have? We are also going to have this other one here, real of z. Remember, when we draw our axes, this is the real axis, the x-axis, and then this is the imaginary. So just like we do for the x and then y, that means the vertical lines are the lines which are written in terms of x is equal to something. Okay, so that one is therefore a vertical line. So this one can be real of z, which is equal to 3, and this one is going to be a solid line. Okay, because they have said less than or equal. Okay, now let us draw our axes here. Now, to be so accurate in your drawing, such that you draw a very good circle, what you're going to do, you can get your ruler and then you measure on your grids. You mark the points such that it becomes very easy for you when you stretch your compass on the ruler and then you draw. Okay, it is going to look so perfect. So I will get my ruler here. So I will put this ruler here and then I will mark the points. Now after that, I'm going to have my center. The center is 4, 3. So 4, 3. I will be maybe around there. Then I will move 2 units. Move 2 units this way, so it will be on 6. Then 2 units up here on the 5. 2 units down here. So meaning this line here, this one here, this line here, and this one here, they are all going to be tangents to this circle here. You see? Like that, they are all going to be tangents. But now I'm going to get my compass and then you draw it perfectly. So you get your compass and then you put it here. This is your center. And then you take it to 2 centimeters. But mine cannot reach 2 centimeters. It actually ends on 3.4. So I'm just going to take it to 4 centimeters. Then I will draw, but then I diminish it. Okay, I will diminish it or reduce it so that it fits in the region where it is supposed to be. So that is supposed to be our circle. And then the other one is real of z is equal to 3. That has to be vertical like that. And this one, I can label it as real of z, which is equal to 3. Now, we want a region that is inside the circle and on the circumference. So inside the circle and on the circumference, that is the whole thing here. And then less than or equal to 3. That has to be on the left of this line. So meaning we are going to shade inside here. It is on the left of the line and inside the circle. This is going to be our solution here. Next, find the greatest value of the argument for the points in this region. Greatest value of the argument of z for the points in this region. Now what we have to do, we go to the origin here and then we draw lines connecting to these points in here. But which line is going to deviate from this positive real axis much more, which one? The line will actually be a tangent to the circle. Okay, so I will draw a line. Let me use another color from the origin here, and it has to be a tangent to that circle. And then we know from circle properties that a tangent and a radius, they are always perpendicular. Okay, so this is 90 degrees here. Now I can take this one here. So the angle that I'm supposed to have, the angle is the whole of this, okay, the greatest argument. But I can split this one into two, and then I have something like this. I connect this one here, then connect this one here, like that. And I can make these ones dotted so that they don't interfere with my shape. Something like that. Even that line there, just like that. So this is 3 units from here to here, okay? And then this is 4 units from here to there, okay? So I'm going to have 4 here to there, and then I can have this angle here. Maybe it is beta. Then this one, I can let it be alpha, okay? So the radius is 2. I'm going to have 2 units here, okay, from here to here. Now I'm going to have this triangle here, the first one here, and then I'm going to connect. This is 3 units, this is 4 units, so this is beta. So opposite over adjacent, that will be tan. So tan of beta, tan of beta, tan of beta is going to be equal to 3/4. So meaning beta is going to be the arctan of 3/4. Let me first leave it there. Then also, using this triangle here, this part here is the hypotenuse. I mean, is the opposite. Relative to this angle, this is 2 units. This is 2. I don't know this length, neither do I know this one. But using Pythagoras theorem on this triangle, I can get this length here. Okay? So we can have this one as the square root of 4 squared plus 3 squared. Okay, so 4 squared is 16 plus 3 squared is 9. So when you add them, that is 25. Then root of 25, that will be 5. So this triangle here is going to be like this. Okay, and this one here is 2 units. Then this is 5. And then this is alpha. So this is opposite and hypotenuse. That will be sine using SOHCAHTOA. So sine of alpha is equal to the opposite, which is 2 out of the hypotenuse, which is 5. So meaning alpha is equal to the arcsine of 3/4. So meaning the greatest argument of z is going to be equal to the arctan of 3/4. Then you add the arcsine of 2/5. So pardon me here. I don't know how I came to write this one here. This is arcsine of 2/5. So then what do we get here when we press everything in the calculator? Shift tan, and then we shall have 3/4, then plus the arcsine of 2/5. This one gives us 60.4 degrees. That is to 1 decimal place. That is if you put your answer in degrees. Or how about when it is in radians? What is it? Just come here and press shift, then mod, and then 4 is for radians, then press equals again. So that will be 1.06. 1.06. Okay, 3 significant figures in radians. So you just write one answer, not both of them. Question 5. Find the exact value of the integral of this expression from 0 to 6. Now, first of all, you can see that when you expand this, so before you do any integration here, you need to first check the fraction you are having. Is it improper or no? What do we mean by an improper fraction? That is the one whose degree, that is the one where the degree of the numerator is greater or equal to the degree of the denominator. What do I mean by the degree? Degree is the highest power of the variable in that given expression. Okay, so when we open brackets here, we are going to have x squared then plus x. That is for the numerator, then over x squared plus 4. So the degree is the same. So now I'm going to first long divide to reduce this one here. So we shall have our divisor is x squared plus 4, and then our dividend is x squared plus x. So you just divide the first, the rest you multiply. So x squared divided by x squared, you get 1. The rest you get this times that 1. So we shall get x squared then plus the 4. Now when we subtract, we shall remain with x minus 4. Okay, so meaning that we shall have this x into x plus 1 out of x squared plus 4. This one is going to be equal to 1, then plus x minus 4 out of x squared plus 4. Since this is integration and I'm seeing x squared plus something, then I can split the numerator here because I can see an arctan and the natural log. So this will be 1 plus x out of x squared plus 4, and then minus 4 out of x squared plus 4. Both of these ones are all over the x squared plus 4. That's why I've splitted the what? The numerator. The integral of x into x plus 1 out of x squared plus 4. Then this is 6, this is 0 with respect to x. This one is going to be 1, then plus x over x squared plus 4, and then minus 4 over x squared plus 4. So from 0 to 6, then here with respect to x. Now we have a variable and then this one here. So when we differentiate with respect to x, this x squared plus 4, we get 2x. Okay, after getting that 2x, we can ask ourselves, what do we do to this 2x to get the x that is here? We multiply it by a half. Okay, so this operation here is what I put on the natural log. So that means here I will have, of course here we shall get x, and then here plus, now a half the natural log of x squared plus 4, the denominator. Okay, then minus. We also have in the list of formulae that if you have the integral of 1 over x squared plus a squared with respect to x, you will get 1 over a, then the arctan of x over a. So my a here, this 4 here is actually 2 squared. So my a is a 2. You see that? So I'm going to have minus 4, then times, because this one is the same as saying 4, the integral of 1 over this one here. Okay, so 4 times, now 1 over our a, which is a 2, then the arctan of x out of a, like that. Then I put the limit 6 and then 0. Then we can put our 6 in here. So 6 plus a half. 6 squared is 36 plus 4. That is 40. Then minus, this will be 2. And then the arctan of our a here is actually 2. Now you put 2 here. 6 over 2, that is a 3. So arctan of 3. And then minus, we go to the lower limit. This will be 0. And then here a half natural log of 4. So a half natural log of 4. And then when we put here 0, so everything will become 0. So we have that. Then we shall have 6 plus a half is common. I can say natural log of 40. Then minus natural log of 4. Okay, this one here, then there is minus 2, the arctan of 3. So simplifying this one can be 6, then plus a half, natural log of 40, divide by 4 using the rules of logarithms. When we are subtracting logarithms to the same base, we divide the powers. So 40 over 4, that is 10. And then minus 2, the arctan of 3. Remember, they told us the exact value. Okay, so I don't need to, you see, the exact value. I don't need to simplify any further. To get the arctan of 3, it will actually be a decimal, okay, in radians. So that is that. Number 6, part A. By sketching a suitable pair of graphs, show that the equation, this one here, has one root in the interval. So I'm going to split it into 2. Then this one is going to be one graph, and then this one is going to be another graph. So I just need a few coordinates. Let me get just 3 coordinates. So let me put them in my table here. So I have x, then I have y1, which is equal to cot, and cot is 1 over tan of x, and then y2 is going to be equal to 2 minus cosine of x. So I can have from 0, then pi over 4, and then this one is pi over 2. So tan of 0 is 0, okay? Then 1 over 0 is undefined. Then tan of 45 is going to be, tan of 45 is going to be 1. So 1 over 1 is 1. And then tan of 90, okay, is undefined. Why? Because we have sine of 90 over cosine of 90. And cosine of 90 is a 0, yet sine of 90 is a 1. So 1 over 0 is undefined. Now, 1 over the infinity you have gotten here, this one will give you a 0. So usually we say that 1 over 0 is undefined. So if I cross multiply and I switch these two, that means 1 over this is 0. 1 over a very big number will always tend to 0, because it will be 0.00000 like that. But if you put this one in the calculator and you say 1 over tan of 90, the calculator will give you undefined. My calculator here is in radians. 1 out of the tan of 90, which is pi, out of 2. Okay, the calculator will say math error. Why? Because in the tan of 90 it has that math error. So this one you have to do it manually. 1, I repeat, 1 over tan of 90 here. This one is going to be 1 over, this one is infinity, and 1 over infinity is what? 0. Okay, so that is that. So meaning here I will have a 0. Then cosine of 0 is 1. So 2 minus 1, that is a 1. Cosine of 90 is a 0. Then here we shall have a 2. How about cosine of pi over 4? That one is root 2 over 2. So 2 minus root 2 over 2. 2 minus the cosine of pi out of 4. Then this one is going to give us 1.29. So let me just put 1.29. Then I'm going to draw these on the same axis here. So those are my axes. Now let's plot this one here for the cot. 0, infinity. So 0 is here on the x, then infinity is here on the y, is somewhere there, we don't know. That means this curve here is an asymptote. Okay, an asymptote is a line that isn't crossed by the curve, and then when it is pi over 4, we are getting 1. So 1 is here, and then pi over 2, that is that. So we are going to connect this one here to this, and then we go like that. It's an asymptote, just following that. Okay, then the other one is 0, 1, which is here, and then 1.29, probably it must be a above this one here. I'm going to connect these like that, and then I will say I'll label them. This is y, which is equal to 2 minus the cosine of x, and then this is y, which is equal to cot of x. So these two are meeting at one value here, okay, at one point. So that means there is one root within that interval of 0 to 90. So within this interval here, they are meeting once, okay. So that confirms our graph. Part B, show by calculation that this root lies between 0.6 and 0.8. Now, if I have a graph maybe like this, and this is x-axis, where this graph cuts the x-axis is the root of the equation. So we have a value on the right of that equation and a value on the left of that equation. So by using this example that I'm using here, we are going to have an x coordinate here, which is x2. It will have a corresponding y coordinate here, which is actually negative because it is below the x-axis. You see that? Then we also have this one here on the left of this root here. But then when we try to extrapolate to the graph here, then it corresponds to a y value which is above the x-axis, which is what? Positive. So meaning that when we have a root, the two values, one on the left of the root, the other one on the right of the root, when we substitute those values into the equation of that function, we must get a change in the sign, okay? There must be a change in the sign. Now, we are going to pick this one here, and we put them on one side, okay? I can put this way, or take this one this side, such that I get a function that pulls everything together, okay? So suppose I bring whatever is here this side. It doesn't matter whether for you take it this side, okay? Now we are going to have cot, which is actually 1 over tan of x. Then when the cos crosses, because it is a negative, it is going to become a plus, and then the 2 will become a minus. So my function in terms of x is going to be 1 over the tan of x, then plus cos of x minus 2. Now I can substitute the 0.6 and then the 0.8. So f of 0.6, what is it going to be? 1 over the tan of 0.6, then plus the cosine of 0.6, then minus 1. So what do we get? Also, we get f of 0.8. We also substitute it in here, tan of 0.8, then plus cosine of 0.8, then minus 2. What does it give us? Your calculator here must be in radians, okay? Straight away, the moment you see a trigonometric function, you must put your calculator in radians. So mine is already in radians. I'll just put 1 out of tan, 1 out of the tan of 0.6. Then I go this side, I put plus cosine of 0.6, and then minus 2. This one will give me 0.287, and the rest of those figures 0.2870 and whatever. Then I go back and I change the 0.6 to 0.8. What do we get? Wherever there is 0.6, I'm going to change to 0.8, and our answer becomes negative 0.3321, 0.332, and the rest of those figures, okay? And it is a negative. So do you see that there is a change of sign? Then we conclude, since there is change of sign, between f of 0.6 and f of 0.8, the root okay, lies between. Now you can just put this statement. The root lies between 0.6 and 0.8. As simple as that. Part C, use the iterative formula, this one, to determine the root correct to two decimal places. So what we just have to do, since they told us that the two values, the root is in between those two values, so I can find the initial approximation, okay? Let the initial approximation be the average of the two, 0.6 plus 0.8 divided by 2, which is going to be 0.7. You can even start with 0.6 or 0.8, but the fact that the root is in between those two, it's better you start in the middle and then you iterate while going this way if the root is this way, or you go this other side. So like that. Now, what is the next one here? So we just substitute the 0.7 in here, okay? We shall have the arctan. Remember, the calculator has to be in radians. 2 minus cosine of 0.7. What do we get? Shift, tan, then 1 divided by 2 minus cos of 0.7. 0.6806, 0.6806 to 4 decimal places, okay? Now, we are going to put this one in here, or in the place of this 0.7. Do not put in your calculator that answer, okay? Just put these 4 decimal places, because usually when you put answer, many times it fails, okay? So x is equal to the arctan of 1 over. In fact, I don't need to write this anymore. You just need to show the examiner that you substituted in this formula at first. So the next, you just go back and substitute. So cosine of 0.6806, that is 6855. 6855. Then the next one, 55, that is 6843. 6843. Then the next one, we put 6843. That is 6846. 6846. Okay. Now, let's check to 2 decimal places. When we check to 2 decimal places, this is 0.68. This is 0.69. This is 0.68. This is 0.68. Now, we have gotten these two values. This is now the minimum number of iterations that we must have. Okay. So we need to put a third one, and then we confirm. You see that? So the third one, in the values that are consistent, confirms the answer. So we need to put back this one that we have gotten, and then we see what we get. So we just come back here, and then we put 6846. So we get 6845. 6845. Now these three all round to the same figure, 0.68 to 2 decimal places. So therefore, the root is that x, which is equal to 0.68 to the 2 decimal places. So this has been it for this first part of the paper. Thank you so much for watching. May God bless you. If you find the content very helpful to you, kindly like, share, and even subscribe. See you in the next videos.